So this podcast is about quantum numbers, and really truly this goes under the quantum mechanical theory or the charged cloud model, the new model, the one that has to do with 1s2, 2s2, right? That's Heisenberg and Schrodinger, and they have to do with orbitals, which are areas in an atom, right? Not orbits, right? This is Bohr model. And Bohr model has orbits, right, which are a set path. We know that's not true today. We're looking at orbitals, which are areas where you can find electrons around in S's and P's and D's and F's. So this is quantum numbers are a way that numerically assign spots in a giant math equation, or the Schrodinger's equation. And these numbers actually are called quantum numbers, which describe different parts in an atom. So there's 4 basic quantum numbers. The first one is the principal quantum number. The second one is the angular momentum quantum number. The third one is the magnetic quantum number, and the fourth one is the spin. So before we even talk about principal, angular, magnetic, and spin, let's go back to what this is real quick. And you need to go back and look at your 1s2, 2s2 type of information. So this 1, what did that mean? That means the energy level that the electron is found on. Okay, and so I'm going to misspell energy level because the principal quantum number is assigned the letter value of n. Okay, so energy level, all right, in bad Bohr model, but you know there's the first energy level, the second energy level. That is the energy level that's found on. This is energy level of 1, energy level of 2, energy level of 3. So the bigger my quantum number gets of the principal quantum number, the further away from the nucleus I'm found, right? Wouldn't you agree that 1s2 and 2s2, that this is on a higher energy level? So the principal quantum number for this would be called 1. The principal quantum number for this would be called 2. Okay, so that's what principal quantum number is. All right, now let's go back to what angular momentum is. So I have 1s2. So if you look at that, that is what? That's the electron configuration for helium. Helium's electrons are found on the first floor, the first energy level. So that is a principal quantum number. Is 1. All right, now where are these electrons found? They're found in the S area. Okay, that's like the sublevel. This is like the level it's on. This is the sublevel. And what are our different sublevels? There's S, there's P, there's D, and there's F, isn't there? Okay, so that's the sublevel it's found on. So this has got to do with the angular quantum number. So this angular momentum is, this is energy level. This is the sublevel, whether it's S, P, D, F, and by the way, there's also G, okay, and it keeps going. All right, so that has got to do with where it's at. We'll come back in a second. All right, what's this? This is how many electrons are found, and where are they found? If we were to draw it, you would draw an electron configuration like this. An orbital diagram is this, isn't it? You have an up arrow and a down arrow. So this right here, this orbital, is my magnetic. That tells me where I am. Okay, and by the way, this has a letter, because of course it does. This is called L. So principal quantum number has a letter of N. This has a letter of L. Remember, these fit in a math equation, right? Okay. And these have a value of 0 to 1. So we're going to call S a 0, because S is shaped like a sphere. P we're going to call 1. D we're going to call 2. F is 3, and G is 4. Okay? All right, now, magnetic has to do what line I'm on. If I have an S, I only have one spot. So So I'm going to call that the 0 spot. We'll come back in a second and talk about this magnetic in a second. What happens when I start adding more lines? Well, this is like a 1 on a number line, and this is like a -1 on a number line. Okay, so we'll come back to this magnetic one in a second. All right? And then I have something called spin, and that is how my electrons are going, either up or down. And this is positive 1/2 because it's spinning up, and this is negative 1/2 because it's spinning down. And there's no better way to really do this than just to go ahead and do some examples. So I'm going to go ahead and do the quantum numbers. And by the way, there's many quantum numbers. I'm going to do a quantum number for hydrogen first. Hydrogen on the periodic table has 1 electron, doesn't it? And where am I going to put it? I'm going to put it in the 1s1 spot with an up electron. So what's the principal quantum number? Okay, what is the N value for hydrogen? Well, it's on the first floor, isn't it? So the first number, quantum number, is 1. That's the principal quantum number. What's the angular momentum quantum number? That's the sublevel it's on. So the L for that is also, well, what is it, S? Sorry, let's go back. S is what again? It's 0 because it's shaped like a sphere. Let's remember that. S's are shaped like spheres. If you don't know that, now you do. For shape, S is shaped like a sphere. It looks like a 0 to me. So we're going to call that, by the way, this is 1. This angular momentum number is a 0. Okay, because that's what it's shaped like. Now, I'll give you a hint. And by the way, we're going to write these quantum numbers like this. We're going to write them out so it's in order. 1, 0. Okay, whenever you have a 0 here, you're going to think eyeballs. So if I have a 0 here, then I'm also going to have a 0 here. We'll go to that in a second, okay? Now, which way is this spinning? It's spinning up. So I'm going to say it's positive 1/2. So these are the 4 quantum numbers that define hydrogen. That electron in hydrogen. That's the quantum numbers for it. Okay? Let's go ahead and do the quantum number for helium. So what is helium? Helium has 2 electrons. What are they? You have 1s2, don't you, for helium? 2 electrons. One spinning up and one spinning down. So what are the principal quantum numbers for that? Right? So the principal quantum number for helium, you have 2 quantum numbers. The first one is 1, right? Why 1? Because that's the energy level it's on. What's the sublevel? Okay, what do we have? S is going to be 0. So we call it 0. Okay, and for starters, you don't know much, but you know that you have this, you're going to have eyeballs, right? Okay, so if this is 0, and this has also got to be 0, just go with me for right now, okay? Now, you have 2 electrons in here, don't you? You have, right here so you can see better. One is spinning up. What is that electron? That electron is positive 1/2. It's spinning up, okay? So now what's this electron? Well, where is that electron found? It's also found on the first energy level, in the S spot, think eyeballs, and it's spinning down, so it's negative 1/2. So this is the quantum number for this electron right here. And this is the quantum number for that electron right there. It's like its address. And if you notice, they're alike in that they have a 1, a 0 on both of them. But this one's spinning up, and this one's spinning down. Okay, so if I have that up electron, it's plus 1/2. If it's spinning down, it's minus 1/2. All right, now, let's talk about this right here. This is N, remember? And this is what? L. Okay, and this has a value of 0 to whatever. Okay, it just keeps going. All right, now, for magnetic, it has a value between L and minus L. Okay, and I won't confuse you with that. I'm going to give you what's called a rainbow. So, if you recall, S's have 1 orbital, P's have 3, D's have 5, and F's had 7, didn't they? I can do this. Give me more room. right? Odd concept, 1, 3, 5, 7 orbitals. So keeping that in mind, this is going to be the S spot. We're going to give it a value of 0. All right, now what about P's? P's have 3 lines, so we're going to go ahead and draw a little rainbow here. All right, these are the P's. And if this is a 0 spot, and you drew a number line, this would be 1 and this would be -1. How many do D's have? 5 lines. So we'll draw a little rainbow. And we'll put a D here. And this would be 2 and this would be -2. And if we draw F's, which have 7 lines, and draw a rainbow, these would be 3 and this would be -3. So I'm going to call that magnetic rainbow, okay? And now it's spin again. +1/2 is up, right? And -1/2 is spinning down. All right, so let's keep that in mind. And let's do the quantum number for the last electron that you put in carbon. So the last electron, if you draw a carbon, what do? You do 1s2, by the way. Carbon has an atomic number of 6. So I have 1s2, 2s2, 2p2. If I was to draw the orbital diagram for that, I would go up, down for 1s2, wouldn't I? Up, down for 2s2. And for 2p, I would draw 3 lines. All right, and Pauli says you spin opposite here, spin opposite here. Here, Han says you go up and then you go up. So ready? What's the quantum number for that electron? Let me draw it like this so you can see it better. All right, so that electron has a specific address. The address is what? Well, what energy level is it on? What energy level? It's on the second energy level. So I'm trying to get a different color, and it's just not working. There you go. It's on the second energy level, isn't it? So what's the quantum number? The quantum number for that electron right there is 2, because it's on the second energy level. So the principal quantum number, or N, is 2. All right, now, what space is it in? It's in the P's, right? And what do we say? S, P, D, F. This has a value of 0. This has a value of 1. This has a value of 2, 3, and if you had a G, it has a value of 4. So what are we looking at? We're looking at P's, and P's are 1. Okay, so it's 2, P. All right, now, what spot am I on? Oops. What space am I in? I am in the 0 spot, aren't I? Right? So my next number here is going to be 0, because that's the spot I'm on. And how's that electron spinning? It's spinning up, so it's +1/2. That's the quantum number series for that electron in carbon. What would be the quantum number for this electron? Well, what energy level is it on? It's on the second energy level, isn't it? So the quantum number for this one would be 2. What sublevel is it on? P, so that would be a 1. Right, that's the L number. This is N, this is L. Right, now, what's my magnetic? Right, this is principal, this is angular. The next one's magnetic. Well, what spot am I on? This is the 0 spot. This is the 1, and this is the -1. So guess what? It's found in the -1 spot. Right? And how's it spinning? It's spinning up. All right? Let's try 2 more. And then I'll do some more in a little bit. So let's go ahead and do the last electron in calcium. What's the last electron in calcium? Well, you have 1s2, 2s2, 2p6. So I go up, down, up, down, up, up, up according to Hun, back, down, down, down according to Hun. And then I go 3s2, up, down, 3p6, up, 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 down, 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 and then I go 4s2. And that's calcium, and we're looking for this electron right here. So what do? I do a principal quantum number, or N, energy level of 4. I do an S spot, because what is it? S, P, D, F, and G. This is 0, 1, 2, 3, and 4. So I'm in this spot, aren't I? If I'm in this spot, I have eyeballs, don't I? Okay, let's see why. This is my L. Well, how many lines do I have? I just have one, so that's like the 0 spot. See right there? That's the 0 spot. How's it spinning? Down, minus 1/2. Okay? All right, let's do this one. Let's do the quantum number for this electron right here. This electron in calcium. What is the quantum number for that electron right here? That one. What is it? Well, what energy level is it on? It's on the 3rd energy level, isn't it? Goodness. It's on the 3rd energy level, isn't it? So I'm going to put a quantum number of 3. What sublevel it's on? It's on the P sublevel. So what is that? S, P, D, F, G. 0, like a sphere. 1, 2, 3, 4. So I'm here, aren't I? So that's 1. What spot am I on? This is the 0 spot always. This is minus 1 and this is 1. So it's going to be 1. How's it spinning? Up, positive 1/2. So if I wanted to, I could go in order. Hydrogen has a principal quantum number. It's 1s1, spinning up. So I would go 1 for the first energy level. S for the sphere, right, 0. Then what spot am I on? I'm on the 0 spot. And how's it spinning? Plus 1/2. That's the quantum number for that electron in hydrogen. What about helium? Helium has not only this electron right here, right, but it also has this electron. So what electron is that red one? 1, 0, because it's an S. 0 because of eyeballs, and it's spinning down. So the first electron in helium is the blue one, and the second one is the red one. All right. What would the next electron be, and what would the quantum numbers be for lithium? Well, if you have lithium, let's go ahead and do this in pink. That's 2s1, isn't it? So lithium's quantum numbers would be the blue one and the red one for the 1s1. And then what would the 2s1 be? It would be on the 2nd energy level. It would be in the S spot. You think eyeballs, right? Because this is a 0 spot and S is 0. So S, P, D, F, G. This is 0, 1, 2, 3, and 4. And how's it spinning? Up. So what would beryllium's numbers be? Let's go ahead and do green. Beryllium would be this, wouldn't it? I would have all those numbers for beryllium, but then I would have 2, yikes, 0 eyeballs, because this is the S spot right here, and it's the 0. And how's it spinning? Minus 1/2. Oh, I goofed on this one, didn't I? This should be positive 1/2, not plus over 2. Right now, if I went on and did boron, what would boron be? Boron, I don't know, let's do gray, would be in the, you can't really see that, can you? So I don't know, let's do brown. Boron would be in the P's, in the 2 P's. And that very first electron goes in this spot. So let's do the quantum number for that. I'd have 2. Now I'm in the P's, so I'm in the 1s. So I have 1. What spot am I in? Not the 0 spot, but the minus 1 spot. So it's minus 1. And how's it spinning? up. So do you see the pattern? These are all quantum numbers for boron. The blue goes with the blue electron, the red goes with the red one, the pink with the pink, the yellow with the yellow, and the brown with the brown. Let's do one more. Who am I? And first of all, is this even possible? Well, look right here, and what did I tell you? When you have a 0 here, you should have eyeballs. So guess what? This does not work because S only has one spot. It's a 0 spot. So that is not possible as a quantum number. That would be the second energy level, the S area, the 0 line. There's no -1 in S, is there? -1 starts on P's. So this is not possible. So what about this? Who am I? What's the last electron? This is the last electron in which element? Well, first of all, what is this? This is 2, so it's on the second energy level. This is N, right? Principal quantum number. This is my angular, right? My angular momentum quantum number. What's that tell me? It tells me my sublevel. So what is it? S, P, D, F, G. 0, 1, 2, 3, 4. So I know I'm in the P's. So it's 2P. Draw 3 lines. This is a 0 spot, this is a -1, and this is a 1. What spot am I in? I'm in this spot. In which way am I spinning? I'm spinning down. So what's that mean? That means in the 2P's, I have to have filled it up, 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 and then down, down, down. So this very last electron is on the second energy level in the very last box, and that will be the noble gas in the second energy level at the end, and that will be neon. So this is the last electron in neon. Let's try one more. So I'm going to go ahead and do the quantum number for the last electron in iron. So we did the noble gas shortcut for iron. The noble gas on the floor before iron is neon. Put it in brackets. And then I do 4s2, 3d. So I go, if I want to combine them, I could do this. Couldn't I? 1, 2, 3, 4, 5. So let me go ahead and put these D's here. By the way, I'm combining these. I'm doing electron configuration and orbital diagram so you can see. So how do you fill up to get to iron? You'd have to go 1, 2, 3, 4, 5, and down. And that is the electron configuration. I'm just throwing the orbital diagram in there, and that's 3d6. So what would be the last electron that I put in iron? What's the quantum number for that? Well, what is it? What's the energy level it's on? The third energy level. Where am I? I'm not in the S's. I'm not in the P's. I'm in the D's. D's are 2. Now, what spot am I in? I'm not in the 0 spot. I'm in the -2 spot. So that's -2, and how am I spinning? I'm spinning down. So that's how you figure out the quantum numbers. And I'll do some more later, but that's a basic introduction.